Hi everybody, this is the Math 20-1 Trigonometry Review. This is question 32E, and I got to look for x here, which is the angle. And now if you look at the information that we're given, I'm given the lengths of all three sides here. With no information about angles, I obviously can't use the sine law for this. This has to be an example of the cosine law. So now to help me enter the cosine law in, I'm just going to label the sides, the angles here I should say, which allows me to also label the sides. And so I can choose the equation that I'm going to use here. I'm going to be looking for angle A. So A will be the inverse cosine function of b squared plus c squared minus a squared all over 2bc. So this will be the inverse cosine of, now in this case here, b is 4.3, so 4.3 squared minus c is 6.2. So 6.2, plus 6.2 squared. Ugh, sorry, you only ever subtract the side squared that's opposite the angle you're looking for. So I'm going to subtract the 3.7 squared, the a squared. Okay, and this is all going to be over 2 times b times c. Okay, now I'm going to go to my calculator and do this. And again, I want you to see what I'm doing when I enter this in. Okay, now it's going to be, just to make this a little clearer, I'm going to zoom in a bit. Okay, so now when we use the inverse cosine, again, what I got to do here, the calculator gives me a set of brackets for the cosine here. I need to include a set of brackets for the numerator. So 4.3 squared plus 6.2 squared minus 3.7 squared. But that's all in a set of brackets, all on its own. I move out of the brackets, divided by, I open another set of brackets, okay, for the denominator, so that the numerator and the denominator, okay, are both in their own independent sets of brackets. And then on here I can go 2 times 4.3 times 6.2. And now I press enter to get the answer, and I'm getting, well, okay, when I round that to the nearest whole degree, 36 degrees. Okay, here we go. So the answer here is 36 degrees. And because the cosine law doesn't have the same sort of issues of ambiguity as the sine law, I know that that's the final answer.